Hello, welcome to this lecture number 4 of CS 1033 Programming Fundamentals. My name is Buddhika Karunaratna and I will be doing two lectures in this course, lecture number 4 and lecture number 5. Lecture number 4 is broken down into 4 parts, so this will be part number 1. So in this course on programming fundamentals, during the first week you were given an introduction, and in the second week, lecture 2, you were introduced to data types, IO, that's input output, and operators. And in the most recent past week, in session 3, you were introduced to conditional control structures. So in this week, session 4, we will be looking at loop control structures. And in the next week, next session will be on lists, numbers, strings. So for all these discussions, we will be taking examples from the Python programming language. Before we proceed to the content of this session, I would like you to try this review exercise number 1. This exercise is on writing a program that reads the marks obtained for a given subject and display the grade. So the setting is given. If the mark is from 0 to 34, the grade should be I. If the mark is from 35 to 39, grade should be D. If it is from 40 to 54, the grade should be C. And if the mark is from 55 to 69, the grade should be B. 70 or above, up to 100, the grade should be A. So this is the behavior, expected behavior of the program. So now please take a moment, please pause the video lecture here and go and try to write this program. Of course we will be discussing this, but I would recommend you to go and write this program by yourself, attempt it, and then we can discuss in the next few minutes. I hope you have gone through the problem and attempted it and try to write the program so that you got the desired output from the program. So here I'm going to present one possible solution for this programming exercise. So why do I say it's just one possible solution? Because there may be other ways of doing it. Slightly changed program would be able to provide the same output. So there are multiple ways of writing the same program and getting the same output. So in this slide I will go through the solution provided here and try to discuss or try to explain what happens at each line of code. So in the first line, there's a variable called mark, and input is taken, or the user is prompted for input. So what is the expected input? Here is the mark, right? So that input is taken in the using the input function, and then it is converted into an integer and assigned to the variable mark. So that is the first line, prompting the user for mark. Second line, straight away we have an if condition. What is it checking? It is checking whether the mark is less than or equal to 34. So if that condition is satisfied, we have another variable called grade to assign the grade, and grade will be assigned I if the mark is less than or equal to 34. So this is checking the grade and assigning the grade. In the third line we have an else if statement, elif, which is checking mark is less than or equal to 39. If that condition is satisfied, the grade will be assigned D. In the third line, once again we have an else if condition checking whether the mark is less than 55. That is, if that condition is fulfilled, the grade will be assigned C. In the fourth line, once again we have another else if checking whether the mark is less than 70, and if that is satisfied, the grade will be assigned B. Finally, we have the else block. If none of these conditions are fulfilled, the program execution will come into the else block, and in that the grade will be assigned as A. So that is the logic that this program is implemented of. So finally, the last line of this program is printing the marks, basically the mark entered by the user, and then the calculated or the assigned grade based on the mark. So finally printing the result. So that is how this problem is approached in this logic. In this way, we have solved, or we have written a program to get the desired output. So now we will look at the exercise that we just completed, that we just explained in a more interactive manner. To do that, we will be using an online tool available at pythontutor.com. So the name of the tool is Python Tutor. So it gives a nice interface and a nice way of analyzing and going through your code, your program, step by step. And will allow us to look at the values of the variables and how those values changed after each line of execution. So in this area you can put in your Python program in the Python tutor interface, and you can edit this code at any time. And you will notice that there will be two running arrows. So one green arrow shows or indicates the line that just executed, and the red arrow will indicate the next line to execute. So at this stage we are at the beginning, so the red arrow is here, and that will be the first line of code that will be executed. So we will start this program. So this is already in the first line, and here you can see the user is prompted to enter the mark. Right, so let's input a sample mark. So I'm inputting 68 and submitting. So here we have now in this step, so you can now see the green arrow which shows the line just executed, and the red arrow is here in the second line, so that will be the next line of code that will be executed. So how do we traverse? Now you can see here in this pane you have the print output. Whatever that you are instructing in your program to print will be printed in this pane. And also notice that now you have the variable. We had a variable called mark, and now at this stage the mark is assigned 68. Why is it assigned 68? Because we input 68. So the program will run based on that. So when we hit the next button, it goes into the next execution point, and now the immediately executed line is shown in green arrow, and the next line would be red arrow, indicated in red arrow. So notice that the mark did not change because initially it was taken from the user, and there was no change. And what happens is now the mark is being checked whether it's less than or equal to 34, or whether it is less than or equal to 39. So none of the first condition obviously did not satisfy, so therefore it goes into check for other conditions. So it now is going to the else if condition, the first else if condition, which in which the mark will be checked whether it is less than or equal to 39. So we can hit next, and similarly to the previous point, it is now just executed the else if condition, was checking whether it's less than or equal to 39. It was not satisfied, and we can go next. This line just got executed, the fourth line, and still you can see the mark is 68, but the value for grade is not yet assigned because none of these conditions so far have been fulfilled. So let's go to the next. So next, when you hit next, this line will be executed, and what happens in there, the mark is checked whether it is less than 70. So let's see what happens when we hit next. Now you see a difference here. The mark was always 68. Now actually the grade is assigned as B, because this condition was fulfilled. The mark was less than 70 and the grade was assigned as B. Did it come into this else block? No, it didn't, because the condition was already, one of the else if conditions was fulfilled already in the previous step. So now it will not go into the, it did not go into the else block. Instead of that, what it did was it went right away into the next line of code, which is the print statement. So let's see what we hit next. Now you can see on this pane the print statement is executed, and the mark is given as 68 and the grade is assigned to be B. So it seems that the program that we just wrote works. So when you enter a mark between 0 and 100, it will definitely give you the corresponding answer, corresponding output, the expected output. However, if you think a little bit more about this, the program may not be entirely accurate, because if you think and input a mark less than 0 or a mark greater than 100, the program will still give you an output, right? So if you enter anything above 100, the grade will still be A, and if the mark is anything below 0 also, it will be giving you the output or the grade as I. So that's not the expected behavior, so that should be prevented. So you can think of how to prevent that. You can think of modifying the same program so that it does not behave in that manner. So that is kind of a take-home exercise for you, and try that out whether you can get that done. Also notice in this interface we don't have the next or the last buttons anymore, because the program is executed, it has completed execution, so there's no more next step. But of course you can go to previous steps if you need and check how these variables change. So this is the outline of the whole lecture 4. So we are currently at part 1, in which we just discussed about how to complete the program, which was in the review exercise. And now we are going to formally introduce control structures, and why do we need, briefly say, why do we need control structures. It's a concept of repetition. So in part 2, we will introduce the for loop, what we refer to as the for loop, and in part 3, while loop, and how to implement nested loops, and why do we need nested loops. So moving on to part 4, we will be talking about some special keywords like the break and continue, where we are allowed to make some changes. We can refer to them as abrupt changes as well. So in which we change the behavior or change the flow of the program execution with regards to um, the repetitive operation. So in the rest of this presentation, we will discuss and you will learn about um, writing computer code or programming code uh, for what we call a loop control structure in the Python programming language. So that will be the main focus of this lecture. And then more importantly, how to use the loop control structure to solve problems. So yeah, it's not just that for our knowledge that we are learning these concepts. We would like to apply them in real world problems so that we can solve them. That is also quite important. So why do we need this control structure called loops? Or simply, why do we need loops? So the main thing, or the main reason that we need loops in a program is to achieve repetition. When we need to repeat the same code block. So that's when we need a looping structure. So let's take this example. So we would like to ask the user um, or prompt the user to enter the marks for a certain subject. So it's something similar in the exercise as well. And with the input, depending on the input, so we make a decision. If the marks are greater than 50, we can inform the user that okay, you passed the exam. So this is one single scenario or one single time that it happens, but how about we need to repeat this for multiple students? Let's say we have 5 students, we need to repeat this. So if we do not think about anything, we can just copy and paste the same block of code for 5 different students, right? So we can have 5, and for each of the instance the code block will be similar and the decision will be made based on the input provided by the user. But okay, 5 students, we can do that, but how about if we had 500 students? Can we even think of managing that kind of code? It would be a very long program, very long computer program, but in terms of efficiency that will be quite low, as you are repeating the same thing. So you have a code block of 3 lines of code and you are repeating that 500 times, and that makes it the program quite an inefficient one. So that's why we would like, say, what if we can take this code block out, right? So this is the repeating code block. If we can get that out and put that in a repeating structure or a looping structure, so that will enable us reusing the code segment, not 500 times, as many times as we want, right? So that's the importance of having repetition, and that is the importance of having a looping structures in a. So now we will look at what are the possible control structures that we find in a computer program. Firstly, we would like to identify sequence of statements or statement blocks. So in this kind of an arrangement, uh, each block comes after another, right? So one after the other, sequential, less complicated, right? So one code line executes, and then the execution is passed to the next line of code. There's no going back. There's no repetition of any line of code or block of code. So it's sequential execution. So far you have seen lots of examples programs having sequential type of execution, which is pretty straightforward. And also during the recent lessons that we have learned, you have also seen conditional structures. So for example, if else or switch case structures. So this branches out. So there's a condition that you check, right, depending on the input. If the condition is fulfilled, you go in a certain path, and if it is not, you go in another path. Eventually you arrive at a certain decision based on the condition. So if else is a if condition, if else condition block is a common example for that kind of control structure, the conditional control structure. And now thirdly, so this is what we introduce as new in this section, the looping control structure. So we have quite common two loop control structures. You have already seen them, the names of them. One is the while loop and the other is the for loop. So for any programming language, those implementations, so those loop control structures would be available. Of course, we will be looking at how they are used in Python programming, but it is not just limited to Python programming. So our goal is to look at programming fundamentals, and as a fundamental concept, we can identify that these looping control structures are available to achieve repetition. So it provides a repeat of a certain code block. Because there can be a condition, and if that condition is fulfilled, you can go to a certain code block which repeats in that circular path. You can repeat a certain block of program. So that is the new structure that we introduce in this section. So we look at loop control structure in a little bit more detailed, and show that how it enables us to achieve repetition. So here in this diagram we have a starting point of the program, and it moves on to check a condition, and when the condition is fulfilled, it goes on to this block of code which is executed, and the program will move on to once again to check the condition. So this happens in a cycle, and until this condition is fulfilled, this operation will go through, the execution of the program will go through this block of code, and it will circularly look at this condition, and until this condition is satisfied, it will execute repetitively this code block. And there will be a time that this condition is not satisfied, and that's when the program will go out of this circular operation or repetitive operation. So what happens afterwards? So there will be some lines of code after this. There will be some set of operations, set of lines of code after this, and those will get executed. So this is a kind of a block, a code block. There was some code before this block, and there will be some code after this block. So it was, let's say, operating in a sequential manner, executing in a sequential manner, and it finds this looping structure and goes on to the condition, and until the condition is satisfied, it repetitively goes through that specified code of block, and then there will be a certain situation, a certain instance where the condition is not satisfied anymore. In that instance, the program will go out to uh, execute the next lines of code which is available in the program. So that is the overview of a looping control structure. We will discuss these control structures in detail in the next part.